Okay. Next, we're going to talk about the difference between mean and median. Both are used to measure the central tendency. Okay? But central tendency, center, or mean and median have different interpretation. Median measure the center of the distribution through middle numbers. And mean measure the center through what? Okay, let's look at here. Say this is a seesaw. Okay? On one end, on the other side. This big and fat guy is Scott. Okay? And this is what? Jenny. Jenny was a student in my class last term. Okay? Jenny was short and tiny. Scott is big and fat. If we both sit on the seesaw, what happened to the seesaw? This is a seesaw. Because Scott is much heavier than Jenny, so Scott will sit on the ground. Jenny will be lifted up. Okay? Now my question is there any way I can balance what? The seesaw. Well, it's very easy. All I need to do is move what? The supporting point. Should I move the supporting point towards Scott or towards Jenny? If you took physics before, you know you should move towards what?
Towards Scott, sir.
Yep, that's it. So even though Jenny is lighter, but her side has a longer leverage, okay? So can balance what? The seesaw again. Okay, can balance the seesaw again. So Scott's side and Jenny's side. Okay? In this picture, the point that balances the graph is average, or you say mean. Okay? The point that balances the graph is average or the mean. So you look at the picture here. Median, measure the center, measure the distribution center through the middle numbers. And mean, measure the center through what? Gravity center. Okay? So mean, measure the gravity center. And median, measure the center through what? The middle number. Suppose we are given a distribution like this one here. Okay? How are you going to describe this? This is unimodel. And right skew. The location that you find the highest peak of the distribution. This is mode. And furthermore, if I tell you up to here, the red shaded area cover 50% of observation. We know the basic guideline on drawing a graph to show the distribution of a variable, okay? How we define this number? This number, 50% of observation, less equal to this number. And we know the basic guideline of drawing a graph to show the distribution of variable. That means under the curve should cover what? All observation, or you say 100% of observation, okay? So by definition, if this is 50%, this side is also what? 50%. So what do we call this point here? By definition, this is median, or we say Q2, the second quartile, okay? So the question is, where is the mean? You have three options. If you choose here, or you choose here, or you choose here, if you choose A, it means you think mean is less than median. If you choose B, you think mean and median, they are the same. If you choose C, this means you think mean is bigger than median. So which one is it? A, B, or C?
B.
To answer the question, let's look at this example first. 1, 1, 1, 1, 2, 2. 3, 3, 3. 5, 7, and 19. This is our X list. Remember, what is the median of X? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Median is a middle number that divides the list into two parts of equal size. For this example, median is what? 2.5. How about mean? Or you say average? You add the number up and divide it by 12. This gives what? This gives 4. Okay? Say, I forget to put a 0 here. If I change 19 to 190, okay? Tell me again, what's the median? Huh? If I make a mistake, this is not 19, this is actually 190. Will median change? Median stays the same, still 2.5. Median remain unchanged. But how about average? Average now become what? Much bigger, 18 point something. Compared to the previous average, is only 4, right? So this one become what? Become much, much bigger, okay? Much, much bigger. What do you learn from this example? A small amount of what? Extremely large X can pull the average towards towards the what? The larger side. Look at the picture here again. A very small proportion of extremely large number can pull the average towards the large side, okay? So average become much bigger. But how about median? Median stays the same. Okay, median stays the same. So what do you learn from this example? We say, look at this example here. A very small amount, but extremely large number will pull the average towards the large side. So average will be bigger than what? Bigger than median, okay? So the answer is C, okay? Conclude from the above, okay? What can we say? If the distribution is unimodal and right skew, okay? Let me rewrite here. If this is unimodal and right skew, like this one here, unimodal and right skew. Mode is the smallest one. and median, the second smallest, and the average is the largest one, okay? So in the unimodel right skew curve, okay, you expect to see mode less than what? Median. Less than mean. How about unimodel left skew distribution? Okay, think about this. Okay, a small amount, but extremely small number will pull the average towards what? The left, towards the smaller side. So now mode become what? The largest one, median, and then smallest one is what? Is mean. Now last one, for unimodel symmetric distribution, mode equal to median equal to mean. A typical example for this is what? Is normal distribution, okay? Okay, the second topic, looking at data relationship. Given a bivariate data set of size n as follows. Bi means 2. x1, y1, x2, y2, up to xn, yn. For bivariate data set, for univariate data set, this is called univariate data set. For univariate data set, we want to study the distribution of x. Distribution means what? What are the possible values? And how often or how likely you see those possible values? This is a distribution. But for bivariate data set, the data come with what? Pairs of observation. So for bivariate data set, we try to study the relationship between x and y, okay? For example, intelligence of husbands and wives, okay? Let x be the IQ of husbands and let y be the IQ of wives. Question, is there a correlation between intelligence of husbands and wives? That is to say, is there any relationship between husband's IQ and wife's IQ? Okay, think about it. Okay, say I randomly select 100 couples, okay? And I recall husband's IQ and I also recall wife's IQ. If I tell you a pair of husband and wife, husband's IQ is 130. You know, IQ average is only 100. Standard deviation is about what? 15. If I say one husband IQ is 130, does this tell me something about his wife's IQ? Yes or no? Is there a correlation between intelligence of husband and wife? Answer is yes. Okay. Now, If yes, what is the relationship? Is the relationship strong? First one. What is the relationship? I find the smarter husband. Marry the smarter wife. And what's the other half? The dumber husband marry the dumber wife. Okay? That's usually the case. And is the relationship strong or not strong? Well, the relation is not strong. Why the relation is not strong? Because I also find some very smart husband marry a dumber wife, or some smart woman actually marry what? A dumber husband. Okay? Make the association not so strong. Now, let's look at the second example. The amount of time spent on test preparation relates to test scores. Let X be the time spent on test preparation, and let Y be the test score. Okay? Amount of time spent on test preparation is, look at here, definition, response variable and explanatory variable. What is a response variable? A response variable measures an outcome of a study. An explanatory variable explains or cause changes in response variable. So let's look at example 2. The amount of time spent on test preparation relates to test scores. Okay? So look at this. Time spent on test preparation and test score. Which one measure the outcome of the study? Well, outcome is what? The test score. Okay? The test score is what? Is a response variable. Some book call this is what? Dependent variable. Or just use DV. Response variable measure the outcome of the study. Test score is the outcome of the study, so it's response variable. Amount of time spent on test preparation is used to explain why some people get high score and why some people get low score. So amount of time on test preparation is an explanatory variable. Okay? Or some book call this is independent variable. Okay? Now, let's look at 3 students in my class. Eric, Yuki, and Peter. Okay? This is time spent. And this is what? Exam score. Time spent and exam score. Okay? Say, which one is the outcome of the study? Exam score. Okay? Peter get what? 95%. And Eric get 90%. Both get A. Why Peter get 95%? Why he got top score of the class? Well, because before the final exam, Peter spent what? 100 hours. Use time spent to explain why he get the top score. Okay? Now, Eric spent 50 hours. And Eric got A. How about Yuki? Yuki get what? 30% in the final exam. So Yuki get F. Why Yuki get F? Because Yuki only spent what? 30 minutes in prepare for the final exam. Okay? Now, think about this. Time spent is what? Response variable. No, time spent is what? Explanatory variable. And exam score is a response variable. This measures the outcome. And this one explains why some people get high score or low score. Okay? Now, look at here. If you can learn, you want to learn from Peter or you want to learn from Eric, both get A. Peter spent 100 hours, get an A, top score. And Eric spent 50 hours, Eric got 90%. Eric also get A. If you can learn, you want to learn from Peter or you want to learn from Eric? I think most people want to learn from what? Eric. But can you really learn from Eric? Answer is no. Because there is another factor, IQ. Okay? Peter's IQ is only what? 90. Slightly below average. Eric IQ is what? 130. So if you learn from Eric, you also only spend 50 hours. You're probably not going to get A. You probably get B or C. Okay? And the smartest student in the class is actually Yuki. Yuki IQ is 180. But in university, okay? No matter how high is your IQ, if you don't study hard enough, you will also what? Fail. Okay? Now, IQ in this example is called what? A lurking variable. Okay? A lurking variable is not explanatory variable, it's not a response variable. But if you ignore this factor, the interpretation on the relationship between time span and exam score will not be what? Accurate. Okay? If you ignore the lurking factor or lurking variable, you cannot clearly explain the relationship between what? Time span and exam score. Okay? So this is called a lurking variable. A lurking variable is not an explanatory variable, it's not a response variable, but it can affect the relationship between explanatory and response variable. Okay?